Hey everyone. All right, our objective in math is not to take too many steps forward. Yesterday we talked about like fractions, so that's going to be important today as well. Yesterday we added like fractions and we kind of talked about the mechanics of how to do that. Today we're going to do something similar, except we're going to subtract like fractions. Okay, so let's take a look. Well, that's not what I wanted. A review of what like fractions are. So just keep in mind, like fractions are fractions that have the denominator, the bottom number, the same. And that kind of makes sense. If you are going to be subtracting baseballs, you want to be subtracting them from baseballs, right? You need them to be the same things. If you have bicycles, you want to be subtracting bicycles. So if you have fourths, you want to subtract fourths. Okay, so the first thing you got to do is you have to make sure that we have like fractions. Second step. Go ahead and think of it like a model, right? There are lots of ways to draw models. They love bar models. They love it. So I'm going to go ahead and use their bar model here. So how much do I start with? Well, I have 2/3. Think about what that is. That's a 2 and then a line and a 3. 2/3. 2 over 3. 2 out of 3. I see it right there. And the reason I know it's 2/3 is because there's 3 parts in all. 1, 2, 3. And I have 2 of them that are orange. Okay? Now 1/3 is taken away, is gone, is used up. So 1/3 is gone. X it out. How many thirds are still orange? Well, just this one. So I had 2/3. One of them got used up. So I still have 1/3 left. I like to just kind of highlight that the top number changes as you add or subtract. The bottom number does not. It stays like all the way through the problem. Like fractions. Okay? Addition is the same way as subtraction in that the top numbers change when you're operating, adding or subtracting, and then the like fractions, the denominators do not change as you do that. Here's another model. Remember, I like the model. All right, so what do we have? Well, we have 4 pieces. 1, 2, 3, 4. So if you look, everything here is fourth. 3/4, 1/4, 1/4, 3/4. Everything's fourths. That's good. That's like fractions. So you have to have fourths all over if you're subtracting fourths. The second thing I like to do is I like to look at the whole. How much do I have all together? Well, I have 3 oranges. 3/4 of the whole thing is orange. That's how much I start with. 3/4. 1/4 gets taken away, gets used up, gets tossed out. How much orange do I have left? Well, I had 3. I took away 1. So I have 2 out of the 4 left. And I see them. 1, 2. Okay? 2/4 would be a good answer. Now, the tricky thing that you're going to bump into is that sometimes the book says, oh, you have the whole thing at the beginning. Well, another way of writing that whole thing is to say I have all the parts that are there. How many pieces are there? There are 3 of them there. And I have all 3. 3/3 is the same thing as a whole. So if you see a whole, feel free to substitute or change it into the fraction because it's going to make the problem easier to work. So I'm getting rid of the whole thing, and I'm now thinking of it as 3/3. I have 3/3. How much do I have? Well, I have 3/3. I have the whole thing. one of those thirds goes away. How many thirds do I have left? Well, I have 2 thirds, and I like to just highlight what changed. The numerator, 3 take away 1 is 2. And what did not change? 3, 3, 3, or I should say third, third, third. So I'm going to show you a couple problems I'd like you to practice for me. The first is you're going to get a picture, and then some of that picture is going to disappear. So it's kind of easy to do. You just have to imagine this is what you have, and that piece is going away. There it goes. What are you left with? Just these 2 pieces. So on these problems, you just have to shade in the pieces you're left with. See? So I had 3 thirds. Someone took away 1 of my thirds, and now I only have 2 thirds that are shaded in. And you can see the same thing up here with the example. You're going to do a few of those for me. Then you're going to get to a different model. It's a bar model, right? So I want you to focus in on what you have. Ooh, I have 1 whole. Well, what do I really have? Well, I have 1, 2, 3 thirds is the same thing as a whole. Thank you. That's much easier. So I have 3 thirds. That's how much I have. I could color it in. I'm going to do it orange just like they were doing before. So I have 3 thirds. Someone takes away 2 of the thirds. They go away. They're gone. They're used up. How many thirds do I have left? I have 1 third left. Right here. You're going to do that with fourths. You're going to do that with thirds. And then right here, I'm just going to help you out a little bit. There you go. 4 fourths is how much you have. The whole thing, all 4 fourths. And then how many of them would have to go away for you to only have 1 left? We're missing this part right here. Can you figure that one out? I'm going to put a little star there. That's a nice little bonus problem. All right? When you get to about here, you can go ahead and rest up. I have a couple more things for you to do on the next slide. Thanks now.